Hey everybody, just wanted to create a quick demo video showing you how to create classes in C++ using C-Line. Obviously if you're using something else, it's a similar process. There's just some features that will be in different locations, kind of depending. There's some features C-Line has that maybe others don't, but regardless, the most important thing is figuring out how to do this stuff in C++. So we're just going to create sort of a fake, or not a fake, but like a different class every few semesters. We sort of change up what you'll actually be implementing at home for your assignment, your project this week. But regardless, this will hopefully help you with that because it should be pretty analogous to what you're doing. So we're going to create a new project. I'm just going to save this one onto the desktop. I'm going to call this college. I'll do something with students. I'm going to do C++ 17, not that it really matters. We're not using any of the new features that have been introduced in the last decade. And so then C-Line's going to think for a little bit, and while it's doing its CMake project down here, sort of building stuff. Over on the side, I'm going to open up the project inspector just so you can see. Here's main CPP. For us, as we start doing classes, most of your assignments are going to be creating these new classes, and so main really doesn't need to play a part as much. Some people will actually create the classes, everything in main. That's not the traditional C++ way to do it. So I'll show you the sort of traditional way that you would do it for most places that you'd work at. You can see it's stopped making, so we're all set to go. And so main is really just going to be used to test our classes, test out the features that we're adding, make sure that they actually work the way we intended them to work. So without anything else, I'm going to right click on my college little project folder up here. I'm going to choose New C++ Class. What this is going to do is it's going to create two files for us, the header file and the implementation file. It's also going to put in some basic stuff like include guards for us automatically, which is kind of helpful. Most IDEs will have something like this, so you don't actually have to create the files by scratch. But again, they're just text files. You could create a file called whatever.h, whatever.cpp, and there you got your header and implementation files. These are just text files. Because this is C-Line and C-Line uses something called CMake, which handles a lot of dependencies for you, it's also going to add that to the target for the CMake project. So in other words, this will be included in the actual executable that you could create when you are creating your program. Regardless, we just have to give this thing a name. So this is going to be sort of implementing like a little college, very simple sort of a thing. So I'm going to call this a student. So we are going to implement a student class. And here I just type the name of the class. I don't have to type in any of the things. It's going to add in the .h and .cpp for me. And hit OK. And so, boom, we've created a brand new class. You can see two files over here, student.h, student.cpp. Student.h is our header file. That's where all of our declarations are going to go. You'll notice that it already put in the include guards for us, so we don't have to worry about accidentally including this multiple times. C++ is very stripped down in terms of it doesn't assume a whole lot, and so that makes it very efficient, but it can also be a little bit harder to use. So in most languages, you wouldn't have to worry about include guards. That's a process that happens on the back end automatically, so you would never include code twice. In C++, you actually have to put in include guards to protect this code. In case you accidentally include something in two different files, then it might actually get included twice in your overall project and cause conflicts with the names of stuff. So regardless, we've created our class. You can see it even has a stub for the class itself, for the class declaration. And that's pretty much what our header file is going to do. It's going to have all the declarations for our class. The CPP file, which all it has is just include student.h, because you have to be able to see the header file to know, what it is. You have to have the header file in order to be able to use objects of that type. And so we have the include student.h, but nothing else here. This is where we're actually going to do the implementations for any member functions that we create in the class. So student.h, let's set up students to do some really basic stuff. I'm probably going to need to include some things here, but not everything that you would normally include. You could include IOStream here if you wanted to. We're not going to use it. because I'm not actually going to do any sort of input-output. I'm just declaring things here. But I will probably declare things of type string. It seems like something I would do. And that may be it. So I'm just going to use using namespace standard. And done. You don't have to do that. You can just put std in front of every string that you create, but it's fine. So then here for class, strictly speaking, I do not have to put the private there. In a class, all things are private by default. In a struct, which in C++ is implemented almost identically, the only difference between the two is that in a struct, things are public by default. So here I don't need to put private, but I always do because I like to have things explicitly labeled. And so here, private, let's create some member variables to represent a student. Probably going to need a string to hold the student's name. Let's do another string to represent the student's major. Let's choose, let's say a double to hold the GPA of a student. And let's do how about how about an int for a student ID, right? In fact, here, just because I feel like that one's even more important, we'll do it like this. So I've got a string for the name, an int for an ID, string for the major. Actually, the ID is probably the most important one, but that's fine. A string for the major and a double for GPA. So this will represent a student for us. We may add stuff later, but for right now, we're good. So then I'm going to create some public things. The first thing I'm going to have to create for the public, we could do a constructor. So a constructor would be helpful. This is generally the second week that we talk about objects. So I'm going to start with the most basic, and then we will add to it as we go. So right now, we're just going to do getters and setters, as well as at least one function, just to be able to print out these values. So what I'm going to do is, let's see here, I'm in public, so let's create our getters and setters. We'll start with the name. So the getter for a name just returns the name of the object that you're asking for. So this is going to return a string, because it's returning the object, or it's returning the name. It's going to be called getName by convention. It's not going to take anything, because objects already know what their names are, right? An object contains a name inside of it, so it can just give you the name. To set the name, that returns nothing. You would call it setName, and it would take a string. Now, I could give that string a name here, but I don't actually have to. I can just leave it as just the type. It's a declaration, so I don't actually have to give my parameters names. And so that would be the getter and setter. We would do that exact same pattern for all four things. Now, I will say, CLion has a nice feature. If I right-click and choose Generate, I can generate some basic code. Some stuff is so formulaic that you could actually just have a computer write it for you. So I'm going to choose the getter and setter, and I'm going to choose ID major, and you know what? I'm not going to include GPA. No, I'm going to include GPA, because we'll need a getter for that. The setter for a GPA doesn't make a ton of sense. You generally are not going to set a student's GPA, but for right now, that's fine. And we'll hit OK, and then it will auto-generate all your getters and setters for you. Now, again, learn to do them from scratch, right? That's important, but it will automatically do it. So here in .h, we can see that it created all the get ID, set ID, get major, get GPA, set GPA. It sort of double spaced everything, which is probably a nice thing, but I'm going to get rid of the double spacing just so it's easier to see on screen. But the other thing that it did is that you notice it has all these like constants. What is this? What is this? Const string alias get major. So the reason it does this is because although mine is very simple, it's actually less efficient. Here I'm, taking a string. Well, when you pass a string, now I'm copying a string unnecessarily, right? I don't necessarily want that. Like, what would be better is if I just sent you an alias to the string that I already have, so I don't have to copy the value of an object. And then if I make it a constant, then I know you can't change my string just because I'm sending it to you to set the major. it's more efficient. And so C-line is giving you sort of the industry, like this is the best practice. However, it's a little easier if you're doing it this way. So your choice. If you auto-generate, you're going to get, at least for strings, because strings are objects, these constant things sort of floating about. And that's fine. But if you don't like it, just do it yourself and don't do the auto-generate. You notice that's not true for like set GPA. This is pretty much exactly what you would expect. It does do a const on the actual function itself over here, but regardless, the auto-generate, it's just doing it a slightly more efficient way, but does the exact same thing. Now, if I go to student.cpp, you'll see it's actually implemented all of these for me. I didn't have to type in a thing. And what it gives me is the most basic functionality. Right here, for set GPA, I send a GPA, and then it is going to assign that value to the student's GPA. Now here it connects it to the class, that's fine. I think I would have done it as this arrow. And the only reason it even has that, right, is because it chose to call the parameter the same name as the member variable. And that creates a name conflict. And by default, C++ is always going to choose the most local definition of a variable name. So here, because this is the most local, had we just not put anything here at all, we would be saying, hey, could you take this parameter, take whatever value it is, and assign that value back to the parameter who you just got the value from. I haven't touched the member variable GPA in the object at all. I'm just playing around with the parameter because that's what GPA means. That's the most local definition. So because it has the same name, you have to put in this arrow, which will say, no, I want the GPA that's a member of this object. Or you could put student : which does the exact same thing. That was C-line's choice. Again, I would probably choose this arrow, but either way. And so you get the exact same functionality. The other thing you could have done is just not create the name conflict in the first place, called this double G, and then just set GPA equal to G. Because this has a different name, now the most local definition of GPA is that member variable inside the object, right? Just pointing out some things that happened with the sort of auto-generating stuff. But any of those are valid choices. Now, the only ones that haven't been done were the ones for name, because I didn't auto-generate name. I actually created that myself. So let's go ahead and do that for name. In general, the pattern for a getter, right? This is going to return a string. Here, because I'm in a separate file, I have to say that, hey, I want the get name for students, right? The one that's a member of the student class. So I actually have to identify that I'm from the student class. The file or the function is called getName, and it's going to take nothing. Right now, I can put in my parentheses or my curly braces and actually do the implementation. The implementation is really simple. I just return name. My keyboard's elevated on this stand, so my typing is going to be awful. All right, but yeah, so here's my get name. Set name is going to be kind of the opposite. It doesn't return anything. It's still a member of the student class. It's going to be called set name, and it's going to call a string, which I will call in, and then I will just set name equal to in. Done. Again, if you wanted to, because C-line has a way of popping up these little labels, like when you try to do stuff, I actually could call this name. If I did that, then I'd have name equals name, have that name conflict thing again, and I would just put this arrow. Or again, student : would do the exact same thing. Just specifying, I want the name that's inside the object, set that equal to the value of the parameter name that was sent to us. All right, so there's my getter and setter for name. I've got getters and setters. We are all set to go, except for one last thing I'd like to do here, which is print. So here I'm going to say that these are my getters and setters. Down here, I'm just going to have miscellaneous functions. I'll just say functions. So these are some other member functions that don't have a specific type thing. And the one I'm thinking of specifically is I could either do void print, right, which is going to have the couts built into the object, or I could actually return a string. The advantage of returning a string with like a toString function is that then I could write this to the screen, or I could write it to a file. I'd have some flexibility. But right now I'm just going to do print because it's easy. So I'm going to create a print function. So you can go up to any student object and say print, and it will print out all the information for that student. Just really helpful for testing purposes. So go back to CPP. Now I actually need to implement this. So here are my getters and setters. I'm going to go down here to my general functions. And of course, the order of this doesn't really matter, but I tend to do constructors and getters and setters above functions. Don't know why, just do. So here's my functions. I can start implementing. This is returns void. It is a member of the student class. It is called print. It takes absolutely nothing because students already know all the information inside of the object. And so now we can actually just print. So I'm going to cout. Let's see here. Oh, this is in red because, of course, I haven't done anything to this file yet, right? I auto-generated everything that's in here, except for the, I guess, one getter and setter. So I've included student.h, but I haven't included anything else. So let's include iostream. Let's include string. Using namespace standard. And if I need anything else, I'll go back. So I've got cout, and then I'm going to print, let's see here, name, colon. Actually, you know what I'm going to do? Just because I think it looks fancy. Do a bunch of these things, /in. Strictly speaking, I don't need to drop this down to the next line, but I often do, just because then it sort of looks in my code the way I expect it to look on the screen. So I find that kind of helpful. It's easier for me to just see, oh, did I forget a new line somewhere? So I'm going to print out the prompt name, and then the actual name of the student, and then an end line. Oops. And then next line, it's going to be how about ID? And then we'll print out the ID of the student and an end line. And then student's major and an end line. And the student's GPA. And then an end line, and then see if I can get these the exact same length. Oop. Done. Semicolon. So this will now print out a student. Based on that, I've got getters and setters. I've got the ability to hold information. I'm going to go to main and start testing stuff. So now for main, get rid of that line because it's no longer needed. I'm going to have to include some stuff. So include iostream. Actually, I already had iostream. Let's include string. But more than that, we also need to include student.h. You only ever include the header file. You don't need to include anything else. But the header file will give you all the declarations, which is what the compiler needs to know if you're actually using this object correctly in all of its member functions and stuff like that. So back to main.cpp. Using namespace standard, let's go ahead and actually create a student. So I'm going to create a student object. Student is going to be called A, because I'm lazy. Now I don't have a constructor, right? So I can't do anything fancy. We're just sort of starting with the basics, and then we'll add as we go along. But for right now, yeah, I've got student A, and I can just use all the setters. So a.setName. We'll call him Harry Potter. and a dot set major. I can actually do this in any order I want. His major would be defense against the dark arts. Does become an or after a while. Am I pronouncing that right? Doesn't matter. And then let's see here, set ID. At this point, we'll do set ID and 1, 2, 3, 4, 5, 6, 7. By the way, you'll notice that IntelliJ tends to pop up these little things here. You don't actually have to type these. These actually aren't part of the code. They're just labels that pop up to sort of help you as you're trying to use functions. Name isn't sending one. I'm not sure why, but that's fine. Point being, you'll see that C-line is trying to help you out, just sort of tell you, hey, this is what it's expecting in terms of an argument. And then a dot set GPA, the only time we'll ever set a GPA. And then we'll just set it to, I mean, he's an okay student, but not the best. All right, so here we go. We've got Harry Potter all set up in our code. I can now do a.print. And that should print out all the information about Harry Potter. Let's see if it works. First build always takes the longest, and here we go. We've printed out the information about Harry Potter. Yes, we got the ID correct, the major correct, and the GPA correct. So now we have the ability to create objects that represent students. That being said, let's make this a bit more complicated and kind of move forward into constructors and static members. So here's something I don't like. I don't like that I am having to choose your ID. That's not the way IDs work. Your student ID is actually a consecutive number. Every student that gets registered with the college, we add 1 to the number for the next student, which is why your number is a lot higher than my number. My employee ID was actually my student ID when I was a student at Fresno City College. And so my ID has 4 zeros in front of it, right? Because I was here longer, or much earlier than you. And so we just keep adding to it. So that would be a nice system to set up so that we can automatically set the ID for a student. And we know that every student would then have a unique student identifier without having to like choose one and accidentally choose one that has already been used. The other thing is that GPA really shouldn't exist. Like you shouldn't be able to set it. That should be calculated based on grades. That's actually going to be a really complicated process. We are going to do a little bit of it, but you know, we want this to be based on a very simple grade object that the students can hold. What else? Yeah, we just need a constructor. We need to do some stuff. So let's start working on that. I'm going to go to student.h. I think one of the easiest ways to implement that student ID is by creating a static member. So we're going to create a static member variable, and it's going to be an integer, and we'll just call it next ID. Next ID. Technically in camel case, it should be a lowercase. I'll do the lowercase because it's right. Although ID always feels like it should be capitalized the whole way through. But so next ID is an integer. Now, here's the weird thing. In C++, I really wish I could just do this, right? I wish I could initialize that variable there. I can't. C++ doesn't allow that. Weirdly, the new version, or I shouldn't say the new version, it's been around forever, but like you can initialize variables that will be part of every object, right? Instance variables right here if you want to. That's doable, but not static variables. The difference between a regular variable and a static variable is that every single student object we create is going to have 4 variables inside of it: name, ID, major, and GPA. But not every object is going to have a next ID. Next ID isn't associated with an individual student. It's associated with the class student, right? And so because it belongs to the class, there's only one. And all the instances share it, or more importantly, like it would be something that only the class would have to keep track of. The class is what creates students, kind of in the same way that, like, I guess admissions and records create students. So then, you know, why would an individual student know what next ID should be given to the next student of the college? Like, that doesn't make sense. There's one number. We want it to be unique for every student. And so we just want the one, right? We don't want to have one for every student. So that's what static means. There's only one, it doesn't get put into every single object, and it's more associated with the class than with an instance of the class. So now we've got next ID. So we also probably want to create some constructors. So let's do that. Constructors. I'm going to create 2 constructors just to show you can override these, and that's pretty common. One is I'm going to override the default constructor because now we have this new ID situation. And so the default constructor that's given to us, because you'll notice we used it, right? I created a student A right here. A default constructor where nothing was sent was called, it was created. And that's given to you free in C++. But I'm going to eliminate that by creating, as soon as you create one constructor, you lose the constructors that were given to you. And so we're going to lose that default constructor, which is okay. That default constructor didn't do anything for us. It didn't initialize strings to the empty string. It didn't initialize numbers to 0. It didn't do anything. So now we're going to create one that actually does something. And it's going to be able to implement that next ID, issuing IDs to students as they go. The other thing is we're going to create a second constructor. This one's actually going to take 2 strings, right? This one, if you send me a name and a major, I'll go ahead and initialize the name and major for that student for you automatically, all right? And so then we can just go ahead and, create this now. So I'm just going to copy these, which I often do when I'm creating functions. Go over here to my CPP file, my implementation file for students. Here are my constructors. Now I'm going to paste. So now this is going to basically be sort of my to-do list for what I have to actually create. For both of these, because we're now in a different file, I need to specify that these are both members of the student class. So student : for both of these. It feels a little weird because constructors are weird. Constructors don't have a return type in front of them. They do have a return type. They return something called like an instance type, but like you don't write it in. It's just you leave that part blank, which means like it feels like when you write a constructor, there's something missing. It also seems a little weird that it's like student : student, but that's just because constructors by default have to have the exact same name, including punctuation, capitalization, as their class. That's what makes them a constructor. So there we go. We've got our default constructor and our other constructor. I'm going to replace that semicolon with a curly brace, and now I'm ready to implement this function. Primary job for a constructor is to initialize all of the member variables inside the object, right? There are other things you might want to do, but at this point, we want to do that. So here I'm going to initialize name. Now this is the default constructor. You haven't sent me anything, so I'm going to initialize name to the empty string. I'm going to initialize major to the empty string. GPA, I'm going to initialize to 0.0. I guess I should just say 0. It's fine. It's going into something that is a double. But then when I read this like explicitly, I'll know, oh yeah, GPA is a double. And then ID, I'm going to assign that to the value of next ID, which is that static member that always tells us what the next ID should be. And so then once I do that, then the next thing I want to do is I want to say next ID plus plus. So in other words, I've taken this ID, I want to increment next ID so that next ID will represent the ID that should be given to the next student who's created, right? So I want to make sure I increase that number here. In all seriousness, next ID is really just the student count, other than I'm probably going to, so by the way, remember how I said you cannot initialize the static member here? It's because you initialize it here in the implementation file, which I find a little bit annoying. But here it's int, and you don't put the static keyword in anymore. That was in the declaration. We're done with that. We just say student dot next ID, and we have to give it an ID. I could start with 0, and then every student would have a student ID that starts with 0. I'm going to kind of force this to 7 digits, so I'm going to choose 1, 2, 3, 4, 5, 6, 7. So my first student will actually be given the ID, what is it, like 1,000,001 or 10,000,001, right? They're going to get some longer ID, and then that way they'll always have that many digits in their IDs. But regardless of where you start, right, it's still basically a count of the number of students that have been created. Now, by the way, this is going to be almost exactly what we do here. In fact, I could have one call the other, but which is kind of a default constructor and then a designated constructor. We don't need to worry about that. For right now, let's keep things simple and copy and paste. The only changes are going to be, I need to give these two parameters a name. Let's say it's name and major. So the name will be set to N and major will be set to N. Done. There are my constructors and the initialization for my one static member. Could I have done things a little fancier? Yeah. So like here I have next ID and then next ID plus right below it. Technically speaking, I could have just done it like that, right? This is postfix notation, if you remember from that week. So postfix notation means that I'm going to evaluate next ID, assign it to ID, and then once that's done, I will add 1 to it. I could do everything in just one line. But for right now, we can keep things simple and not try to do 2 things in one line of code, although 2 things is probably fine. Like that's still pretty clear. If you start trying to do 18 things in one line of code, then you're so clever, but your code is unreadable. So somebody's going to throw a stapler at you in the break room. All right, there we go. We've got some basic implementation. Let's see if it works. I'll go back to my my main.cpp. And we are now kind of done with this. Here. When I create student A, I'm going to actually send some values. Harry Potter, Defense Against the Dark Arts. Done. We're no longer going to set ID. We're no longer going to set GPA. In fact, we probably want to go in and get rid of those setters. You have a GPA of 0 because you just got here. You've got, your ID was automatically assigned to you based on the next ID, so I don't want you to change it later. But we can also create a couple more students so I can see if that functionality with the next ID is working. So Hermione Granger, and her major would be everything. Let's just say, doesn't matter. I can't remember. It's fine. We'll just say herbology. Done. Although, yeah. And so then I can do a.print, and now I can also do b.print. And let's see what we got. Hopefully people with consecutive student IDs. And let's raise this up. Harry Potter, ID 100001. Defense Against the Dark Arts, GPA of 0. Hermione Granger, 100002. Herbology, GPA 0. Perfect. All right, so we've created 2 students. The ID seems to be working, so we have that one static ID that's not associated with the student, but associated with the class in general, that we can use to hand out the correct ID for every new student we create. So that seems to be working. Let's make it more complicated. We're going to talk about composition, which is the idea that your classes can actually have other classes sort of nestled into them. We can have a relationship between things. Right now, the one thing I can't really do is that GPA, right? Like you have a GPA, but like how do I calculate it? Well, I calculate it using a grade. But grades are kind of different, right? Because if you get an A in a 2-unit class, that doesn't have the same weight as getting an A in a 4 or 5-unit class. So let's go ahead and try and implement a brand new class. I'm going to click on my project folder up here, right click, new, C++ class. Now really this class I would actually make as a struct, right, just for grades, because I think of a grade as just a collection of data. And so struct makes a heck of a lot more sense to me. But I'm going to do it as a class just because we're creating classes, and so it's fine. Remember, in C++, there's no difference between classes and structs. It's just a matter of which is public or private by default. Private for classes, public for structs. So this is going to be a grade class. It's just be a class that holds grade information, and I could then use in a transcript or something. So then, let's see here. How about, we'll just make everything public by default. Now I don't have to create getters and setters again. You've already seen me demonstrate that. So we're just going to make everything public so we can access it directly, which is basically going along with my idea that this is probably better off as a struct than a class. I'm not going to have a whole lot of functionality with grades other than maybe the ability to print them, and yeah, really simple stuff. So what does a grade need to have? A grade needs to have, well, let's include the string class. We'll use using namespace standard. And so I want to create a string for the course, right? Because you get a grade for a particular course. Sometimes that's important when I go back and look at your grades to see, oh, well, but did you get, a grade of B or higher in this particular course that maybe I care about based on your major? I don't know. It's important to know what the course is. There's going to be an int for units. I suppose technically some classes could have a half unit, but keeping it simple. Int for units. And let's do a char for letter grade. Now, based on the letter grade, so to calculate GPA, we want to convert letter grade into something else. Now, I could just store it as one thing. That would make more sense. I could either do like grade points, which is 4 for an A, 3 for a B, 2 for a C, etc. Or I could store it as letter grade. Really, either way works. So, yeah. Do it however you want. Here I'm going to actually create, though, that int for the grade points, just because it'll be easier to calculate later on. Let's do, I suppose we're still in public here. Let's do a quick constructor for grades. So, in fact, I'm going to make it so you have to, when you create a grade, you have to send some stuff. You have to send the course. You have to send the number of units. You have to send the letter grade. Done. Grade points, we'll just calculate that based on the letter grade. So I've got a constructor for grade. And I do want to have the ability to print my grades. So I'm going to do void print, kind of like I did with student. All right, done. These are the only two things I need to implement for this. I don't have any of the getters and setters. So copy, go over to grade CPP. We're going to include IOStream. We're going to include the string library, and using namespace standard. Bam. Okay, so now print. This is my to-do list of things I need to actually implement. So first thing I want to say is this is a member of the grade class. It's going to have a string for the course, an int for units, and a char for your actual grade. Char is just character. All right, and so now I can actually implement this. Most of these are going to be pretty straightforward. Course is going to be equal to whatever course you sent. Units will be equal to whatever unit amount you sent. Letter grade will be equal to whatever character you sent. Actually, I'm gonna add some additional functionality. If you send me a lowercase a, I'm gonna convert it to an uppercase a. right? Just right off the get-go. So there's a function in C++ called toUpper, or twoper. We're just going to, toUpper is, we're going to call that on G so that we get a capital G. I could probably also put in here some checks to make sure that it's either A, B, C, D, F, or I, or X, or there's a couple other weird ones. But like, we could do that. I'm not going to. We're just going to assume that you actually are going to send a valid grade. Technically here, you could get a grade of Z just because I didn't check and prevent that. And then the last one I'm going to have to actually calculate. I could do a whole bunch of like if, else if, else if, else if, else if, else. But what I'm actually going to do is just I'm going to switch. I'm going to switch specifically on letter grade. So we just set that. And now I can just do a bunch of cases. So case capital A. We can say, what do I call it? Grade points. Yeah, grade points is equal to 4. Break, sort of G plus or C++. B grade points equals 3. Break. Okay, and by the way, if you wanted to do this as a whole bunch of if-else statements, that also is perfectly valid. There's probably even a really fancy mathematical way I could have done this by just like, because each of those capital letters is actually an ASCII value. In fact, I want to say 55 for capital B, so that would be 54 for capital A. I could be off on that, but then like I should be able to create an actual mathematical formula to just set grade points, and that would actually save me clock cycles, which is good. I like that. But again, we're going to keep stuff simple, as simple as we can, right? For right now. But those are the, didn't put a break in. That would be bad, because remember, if you don't have a break in a switch statement, it just keeps going through all the cases and doing all of those lines of code. So I would actually end up setting grade points to 2 and then setting grade points to 1, because it would do the D's case as well. Grade points equal to 1. Break. And then my default case is just going to be grade points equal to 0. Again, there should be something where like incompletes don't actually count against your grade, etc. But for right now, we're just going to switch on letter grade and set the value of grade points accordingly. I could do this at the time that I'm calculating, but I don't know how many times I'm going to need to do that. So I'd rather just do it once and just store that value real quick. All right, done. So this actually will create a grade object for us pretty quickly. Now for the print. I need to say that print is a member of the grade class this time. And let's see here. We are going to cout. Do I care? No, I don't. I'm just going to do a bunch of these dealios and a new line. And then I'm just going to do this transcript style. So it's going to be course, maybe 1, 2, 3, and then units, and then 1, 2, 3, 4, and then we'll just do the grade, letter grade. We'll use the grade points for calculating GPA, but that'll be sufficient. And then end line, and again, you could do this, print this out any way you want. I'm going to then attempt to get these two lines the exact same size. Actually, I don't need the second one. Because if I print out a bunch of grades simultaneously, then we'll just have one line in between each. All right, there we go. So there is my very simple printing of a grade. So now, why do we create a whole separate class? It's because there's a relationship between students and grades, and so I want to show that relationship. If I go to student.h, I could actually give a student the ability to hold a grade. I could do that. Well, I'd have to include grade.h here in my header file for student, but then I could, create a grade called grade. Done. A student can have a grade, but that's not really kind of how we'd want to do that. That would be like a one-to-one relationship. If students only ever had one grade, then that would be it. But students actually have multiple grades. Now, the best way to do this would be with a vector, but we haven't talked about vectors yet, or generic programming. And so instead we'll do it as an array. C++ arrays are kind of limited, so we're going to need to do two things, or add two things. This is going to be a grade array. Now, because it's an array, I'm going to call it grades, right, plural, so we know there's more than one. And I'm going to have to set an arbitrary limit, right? There's going to have to be a certain number of classes you can take, and you can never have any more classes. Let's say that number is, if you were to take 5 classes a semester for 4 years, that'd be 10 a year, 40 classes. Most students, let's just double that. All right, so if you went to school for 8 years, right, we could hold, and with a full pace, that would be the number of classes you could take. Again, this is a demo, so the number is completely irrelevant. What's relevant is that, well, I need to know that. What's relevant, though, is that I need to know how many actual grades I've put into your array, right? In fact, because this is, oh no, I can't do that. Because grades holds grade objects, not numbers. So let's see here. I need to keep track of how many actual grades I put into your array so that I know kind of how far to go when I'm calculating GPA. Like if you've only taken 3 classes and there's only 3 grades there, I need to kind of know that. So for every single student, I'm going to have an int with the num of grades. I'm just going to say grade count. That seems better. All right. So now I've created 2 new things. That means I'm probably going to need to adjust my constructors a little bit. I probably also want to add getters and setters, but actually, no. Now, I mean, theoretically, I'd want to get grades every once in a while, I suppose, on a student object. But for the most part, I don't care. This is all going to be held internally, and we're just going to print it out with the transcript for every student. So then let's go to my student.cpp, and suddenly doesn't like this. But one of the things I'm going to need to do is say grade count is equal to 0. And grade count is equal to 0. And suddenly don't know why it doesn't like that. Did I do something to the header file accidentally? I didn't mean to. No, you were working fine just a second ago. I'm going to call this just a constructor for student must explicitly initialize member grades, which does not have a default constructor. Oh, okay. So I just apparently do need to actually implement it. How about this? Oh. So in C++, because I've created an array for grades, but my grade class itself, these are the weird errors that you'll run into, but you may have run into this at some point too, so I'm glad I ran into it. When I created the constructor for grade, I lost my default constructor for grade. The default constructor for grade is really useful, in part because it tells it tells the compiler how big a grade is, right? It uses the default constructor to do that. And so you can't create an array of grades unless you know how big a grade is. So we need to have that default constructor for grade. So that means I need to go back into grade, and all of this work that I did, don't care. This is default constructor. We just need to make it. In fact, how about this? Let's make this even easier. I haven't even declared it yet, have I? Nope, perfect. Okay, so then for me, I'm just going to right-click here, generate constructor. We're going to select none. Did I already define it? Did I already define it and I lost it? Anyway, you can see right here it's actually created a default constructor for me. And if I go to the grade.h, oh, I did already put it in there somewhere. And so here I've declared it, and then in the implementation, it's been implemented, and it's been implemented to do nothing. But that's okay, because it doesn't need to do anything. Like, it's going to create those three variables. It's going to have the size. I just need for the other file to be able to actually call that. Okay, so if I go back to student.cpp, these should be happy. They will be happy. There we go. They're now happy. And so grade count 0. We're good. All right. So now I can store grades. Now I just need to be able to calculate your GPA. So weirdly, GPA here is a stored variable. If I were doing this for real, I might actually create like GPA as a function. It's something that gets calculated every single time. But for us, I suppose we could, waste a little bit of memory in order to save clock cycles, and we could just calculate it once every time we add a grade. Notice we're not going to get rid of grades and stuff like that. You'd want this to be a lot more complicated in the real world, but in student, we are going to add a new function. Our new function is going to return nothing. It's going to be called add grade. Sure. Add grade is going to take three things. I'm going to want you to say, what's the course? So it's going to be a string, an int for the units, and a char for the actual grade. Makes sense to me. All right. So then those are the three things, by the way, that you need in order to create a grade object. So add grade is just going to create that grade object for you and then add it to the array for that particular student. Copy. Go down here and paste. And so then these parameters are going to, well, I need to say that this is a member of the student class. Then these strings are, or these variables are going to need names, the parameters. So string course, int units, char grade. And the first thing I'm going to do is actually create that grade object, right? So grade is going to, actually, I'll just do it sort of locally. I'm just going to send the course, the units, and the grade. And actually, still like to put spaces there. So that'll create my grade object for me. What else? Now that I've created the grade object, and by the way, remember our grade constructor will actually calculate the grade points for that grade, so we're good there. So then I want to actually add that grade to the student's grades. So grades, and so here's the thing, remember, your grade count starts at 0, and your first grade that I want to enter, I want to put it into that array at index 0. So grades sub grade count is going to be equal to grade. Right, I'm going to want to pass that over. So now that I've assigned that a grade object, I want to, grade count plus plus. Let's add to the grade count because you now have a grade. I want your next grade to get put into slot 1. More importantly, you have 1 grade, right? So the grade count is now correct. By the way, and again, I could do that in a fancy way by putting the plus plus at the end of grade count in the previous line, but I'm going to do one thing per line right now. Keep the code simple and straightforward. So the other thing I'd want to do is every time I add a grade, I want to update your GPA. So here I've added the grade there. In fact, here I'm going to even put in some notes so people can see what I'm doing. Add grade to students' grades. The next thing I'm going to do is update GPA. So the way you would update a GPA is to go through all the grades that you've had. We've got to multiply the grade points, that's the 4, 3, 2, 1, 0. Multiply that by the units. And then when we're done with everything, divide by all the units, right? So I'm going to create 2 new variables. One is going to be, I'm going to make one of these a double, just so that I end up with the correct division. Actually, no. We'll do the casting probably the way it should be done. So int grade points, or better yet, total grade points equals 0. Int total units equals 0. And now we can actually do the calculations. So first I got to get the 2 running totals. So that's going to be a simple for loop. So for int I equals 0, I less than your current grade count. So remember, if your current grade count is 1, we're going to start at 0. We're going to calculate the one at index 0, and we're never going to get to 1 because 1 is not less than 1. So that's perfect. You have 1 grade. I just want to get the one at 0. I don't want to continue on to the actual grade count because that one is going to be a fake. There's no grade object there. And again, there's no way of editing this like to get rid of grades later, but we're keeping it somewhat simple. And so then I plus plus. And so for each of these, I'm just going to say total grade points plus equals, and here it's going to be grades sub I dot grade points times grades sub I dot units, right? We're wanting to multiply the grade points by the units because, again, an A in a 5-unit class means a heck of a lot more than an A in a 2-unit class. And same thing here, total units plus equals grades sub I dot units. All right, that's it done. Oop. So we just want to calculate the total grade points, total units, and then we can say we want GPA to be equal to, and this is the GPA for the individual student, total grade points divided by total units. Oops. But this is an integer and this is an integer, which means that division is going to give me integer division. It's going to give me floor division. It's going to give me a whole number, which is not your GPA. I want something different than that. So what I'm going to do is take one of these and just cast it as a double, just for that one calculation, because I want to get the actual number just for GPA. Total grade points and total units are actually integers. And again, I could have just made one of these a double up here, or made both of them doubles, and that would have worked. But, you know, maybe this is the slightly more correct. Honestly, I don't care. Your choice. So here we go. Update GPA. We've now updated the GPA every single time you add a grade. Now notice that's the only time that the GPA is updated, so we would have to do the exact same thing if we were to ever remove a grade. That's a really inefficient design. GPA should probably be represented differently, but for right now, we're okay. All right. So then, add grade, update GPA. Let's test this. Oh, actually, no, I want to do one other thing. My print function seems out of date now, because now I've got all this grade information I can print about a student, but I don't do it. So instead of just ending here, we're going to for int I equals 0, I less than grade count, whatever the grade count is for that individual student, I plus plus. And so then for each of those grades, I'm going to say grades sub I dot print. So every single grade that you've actually got, I'm just going to print out all your grades. But your GPA should now be up to date. Let's test this. By the way, this is, again, composition. Now students have a relationship with grades. Students have grades, right? Students have, in this case, mini grades, because I've got you know, a whole array of grades that a student can have. So students have multiple grades. You notice I've actually sort of composed the grade class, or you know, instances of the grade class into my student objects. So, yay, complexity. Here I no longer care about Hermione. We're just going to deal with Harry Potter. But we got to give Harry some grades. So let's see here. A dot add grade potions. Let's say potions is a 4-unit class, and Harry got a B in that class. You know what? Let's be realistic. Snape was teaching it. A dot add grade. Let's say defense against the dark arts. So that would be, let's say, a 3-unit class, and he got an A. Oops, we're sending characters. In fact, I'm going to send a lowercase a, because remember, we have that functionality. It should be able to fix it, even though I put in the wrong thing. And so then a dot add grade. Let's do one more. How about transfiguration? And transfiguration seems like another 4-unit class, and let's say he got a solid B in that class. All right. So now I'm hoping that he has a I can't even do the calculation in my head. I'm just going to run it and assume that this is true. All right, let's see what we got here. Harry Potter. That's his student ID. We know that functionality works. His GPA is below 3, which makes sense because he got an A in a 3-unit class, but he got a C in a 4-unit class. It's going to drag him down a bit more, and he would end up getting a 3 for the B in the 4-unit class. But there's his transcript, his different classes with his grades, as well as his overall GPA that's been sort of locked down. We could round that off if we wanted to, but you know, I'm fine with this as is. So there we go. We have a set of classes with different elements to it, classes with relationships to other classes. We could talk about subclassing at some point, but I think for right now this is probably good, and we can pick it up with another demo later on. If you have any questions, feel free to send me a message through Canvas, and I'm going to upload this code so that you have access to the different files. I probably won't send all the other stuff. I'll just send the college folder with just the .h and .cpp files so that you can kind of look through them and use them as a template as you're creating your own classes. But hopefully I also showed you a few of the features in C-Line that can make life a little bit easier for you. There's a reason I chose C-line because it does tend to make life a little bit easier, especially if you're trying to implement something that has, 30 different member variables. Creating automatic getters and setters is kind of a win. So anyway, if you have any questions, send me a message in Canvas.